In this video, we will look at how to graph functions. There are several families of functions that we should be familiar with. First is a linear function where f of x is equal to ax plus b. Linear function means it's a line. So when you graph this, it becomes a line. Quadratic function, as we all know, is an ax squared plus bx plus c, where it's either concave up or concave down. Cubic function is a function that starts with x to the cube. So looks somewhat similar to this one. If a is positive, if a is negative, it looks like this. Exponential, we already looked at this. F of x is equal to a to the x, where a has to be greater than 0, but a cannot be equal to 1. General graph of exponential function will look something similar to this one. Logarithmic, log functions, if f of x is equal to log base a of x, then it looks similar to this guy. Reciprocal function is basically the function that we've looked at a couple times. F of x is equal to k over x, where k is a constant and x cannot be equal to 0 and k cannot be equal to 0. It looks similar to this. All right. We need to look at a couple terms in here. When we say intercepts, has an S in it, so it means x-intercept and y-intercept. So we're talking about both. Turning points means local minimum or local maximum. Minimum or maximum. So in quadratics, when we get a graph looking like this, we have a minimum in here. When we have a graph that looks similar to this guy, we have locally it's a minimum. Around here, it's minimum. Around here, locally, we have a maximum. Locally, we have another minimum. Locally, we have another maximum. Those are the turning points. Then we have asymptotes. Asymptotes are either the lines or curves that the graph is approaching. So the graph is not going to cross an asymptote depending on where the asymptote is. For example, f of x is equal to 1 over x. The graph is going to reach the y equals to 0, but it's never going to cross this line. Same idea, it's going to approach x equal to 0, but it's never going to cross this line, and it's the same on the other side. Consider the function y is equal to 2 to the x over x minus 2. Use technology to help answer the following. Find the axis-intercepts. In order to do that, you need to first draw this graph. Then you will get the following graph. Then, in order to find the axis of intercepts, go to second, calc, which is the one above the trace, then go to 0. You want to click somewhere above the x-axis, somewhere below the x-axis, in order to find this 0. x1. Repeat the same process. You want to click somewhere below the x-axis this time, and then above the x-axis. Then it's going to return the value of another 0 on here, x2. Once you do that, you get an x1 of 1 and 0, another one, 2 and 0. B. Find any turning points of the function. When we say turning points, we are referring to the minimum or the maximums. So in this graph, we have a minimum. This time we're going to go second, calc, min, Then you're going to click somewhere on the left side of the minimum, because we know minimum happens somewhere around here, not knowing exactly where, and click somewhere here. So once you do that, you get a local minimum of 1.44 and negative 0.116. Then C, find any asymptotes of the function. In order to find asymptotes, we need to look at as x is approaching infinity or negative infinity, what happens to the y value, and sometimes it's obvious and sometimes it's not. Oftentimes we can expand the window size, so instead of making it this zoomed in, we can zoom it out a little bit and see what happens to the left side and then the right side of the values. Once you do that, it looks like on the right side it's always increasing, so there is going to be no asymptotes on that side. On the left side, it gets closer and closer to one value, and we don't know for sure. In that case, the tables come in super handy. Second table, which is one right of the trace, and then if you look at the values of x and y, at x equals to 0 and y, it says it's arrow, and we'll talk about that soon. And -1, -2, -3, and so forth, the y value is -2.5, -2.125, -2.042, and so forth. So as you scroll down, you see that as x is increasing, the y value is approaching -2. So as x is approaching negative infinity, y value is approaching -2. So in that case, we know that the asymptote is at -2. So y is equal to -2. Let's go back to our table of x is equal to 0, y return the value of an arrow. That is because that's where the asymptote is. The vertical asymptote, as the number is increasing on the positive side, over here on the graph, it's approaching 0, but it's not crossing the 0. It's the same idea over here. It's approaching 0, but it's not crossing the 0. So at x equals to 0, we have another asymptote. So when it says state the domain and range of the function, that's an easy one. After we find out the asymptotes, the domain is going to be all real numbers except at 0. And for the range, we're going to have all real numbers except 2. That would be a huge mistake, because at -2, we know that everything exists below -2. So it's okay to say y has to be all less than -2. But what about if it's greater than -2? The value is not defined, right? From this asymptote up until where that minimum is, this whole zone is not defined. Therefore, y value must be greater than or equal to our minimum that we found, the -0.116. So by setting it this way, we're not including the zone of the blue where the graph is not passing through at all. Alright, that was a little tricky, but be careful when you do these types of questions. For E, sketch the function showing its key features. In order to do that, you need to show its minimum and the intercepts and the asymptotes, and graph as accurately as possible. Draw the functions y is equal to 1 over x and y is equal to 2 minus x on the same side of the axis with the domain between -4 and 4. So one is a reciprocal function, the other one is a linear function, and this one is easy to draw, so that shouldn't be a problem. B, hence, which means use the informations above, find any solutions to the equation 2 minus x is equal to 1 over x on the domain of -4 and 4. So when two graphs are equal, that means where they intersect. You can find the intersection on the graph by going to second calc intersect. Click the linear function and click the reciprocal function, enter one more time, then you're going to get a value of 1 and 1. That is the intersection. So that's when two equations are the same. C, on the domain x is an element of a real number. For what values of k does x plus 1 over x is equal to k have one solution, no solution, or two solutions? So x plus 1 over x is equal to k. If we rearrange this by subtracting the x on both sides, we get 1 over x is equal to k minus x. So this is a graph that is very, very similar to what we have over here, except now this value of k is not equal to 2. K is just a constant. So when are these two graphs going to have one solution? That means when are they going to intersect exactly at one place? We've already looked at that. It's exactly going to have a one solution if it was a line that passes through here or a line that passes through over here. So k must be equal to 2, or k must be equal to -2, because they are symmetrical. All right, next, when are they going to have no solution? They're going to not intersect at all if the value was between these two purple lines. So for no solution, if k was in between -2 and 2, it will have no solution. When is it going to have two solutions? That means it's crossing at exactly two places. So it's not tangent to the blue curve, but it needs to pass through. So it needs to be, for 3i, k has to be less than -2, and k has to be less than -2 and bigger than 2. If it's bigger than 2, we're going to have a graph that looks like this, and it's going to pass through 2 points on that graph.